Awesome. Thank you, Rachel, for that introduction. Hi, everyone. I'm Holly, and then I have Rob with me as well. I'm one of the program managers here, and we're excited to have this time with you all. It's kind of a new webinar presentation that we've done just to have questions submitted. So we appreciate your engagement in submitting those questions. We've been doing engineering for the signage industry since about 1984. So we're excited to share some of our expertise with you all today. So yeah, anything you want to add?
Yeah, just already good questions. Look forward to answering them. I kind of half jokingly, half truthfully call this Stump the Chump. So these are some good questions, and I look forward to answering them.
Yeah.
All right, we'll go ahead and start stumping then, Rob, if you will. So the first question from the group was just telling us, what is a day in your life as an engineer?
So as you can imagine, it's all across the board, and it's all different for all the different people in our company. For one of our designers or engineers who's heavily focused on projects, it is typically working on one project with brief interruptions about other things. We try to keep our designers and engineers focused on being able to concentrate on one project. People like myself or Thomas Gammon, who some of y'all may know, our days are totally scattershot. It just depends. We're responding to requests from clients, proposal requests, urgent field questions. That's one of the things that we always like to remind people: when you're in the field and something comes up, please give us a call. So it truly, there are days when we get to the end of the day and we don't know what we did or how we spent the time, because it is just so busy and full, which is a lot of fun. It's very interesting.
Holly, do you have anything to add, or are we going to go straight to the next question?
I mean, my day, so as a program manager working here, I would say my day kind of is a mix match of answering questions, helping with proposals, working on structural inspections. So I don't get to stay focused on just one thing, but that's what makes it exciting.
Awesome. What is probably one of the weirdest problems that you've ever had to solve as an engineer?
This was a fun question, and there are a lot of, it depends on how you define weird. Sometimes I think of it as interesting and challenging. Sometimes I think of it as truly weird. So for an interesting or challenging project, a couple things come to mind. One is, for those of you who may be familiar with MLS soccer, the FC Cincinnati stadium that was built a couple years ago, we did the entire secondary frame structure for that stadium. And it's 360 degrees, all these different frames that are differently shaped, and they have an LED strip on the outside, so that it's a full, essentially a video display around the stadium. But everyone's different, ranging from 6 feet tall to 40 feet tall, and how to fit that into the primary stadium structure when the designers didn't really incorporate the loads from the secondary structure was quite a challenge. Very interesting. Certainly some of the more weird ones, but fun ones are old historic signs. We do a lot of marquees for historic theaters, and trying to work within a National Historic Registered landmark and make that signage work was a lot of fun. But I have to say, the weirdest project we've ever done was for the Mascot Hall of Fame, which I didn't even know existed. It's outside of Chicago, and on the outside of the building, and you can Google this, it's a mascot is built into the building. And so we designed a 14-foot projecting pink nose for a mascot. And the actual loadings from it was an interesting challenge, because it was so loaded in a cantilever way. If you do Google it, I will say there is an object dangling from the nose. We did not have anything to do with that, so we do not claim that at all. But the pink nose, Pepto-Bismol pink nose, we designed, and that was probably the weirdest thing I've been a part of.
Awesome. How do you approach a problem solving when you might be stuck on a project?
Again, that's a great question. Part of it is the way as an engineer you're trained is you break down problems into smaller and smaller components. And so if you're stuck, you solve what you know. But then, okay, so that's a good theory. We were talking amongst ourselves yesterday about it, and frankly, one of the things we do is you stop working on the problem, you get up and walk around, and sometimes even start on another project, and then it'll come to you. So just kind of clearing your mind. You can get so roadblocked. We do have, amongst the two offices, we've got 24 people, so there is a lot of dialogue that happens about complicated projects and getting other people's insight. So we strongly encourage our younger employees to use other people, use their knowledge and experience. But just on a practical basis, break it down into small steps, just one bite at a time, and then taking a break. And it's amazing how many times you hit a wall, you go home for the day, and then you sleep on it, and literally you wake up and you've fresh set of eyes and you figure it out. Which is probably how all of y'all solve the problems too.
It doesn't hurt getting reminded of that, I think.
Engineers are humans too.
Okay, so now we're going to kind of get into some more specific questions that were sent in. What is the best fastening method or methods for installing a sign onto concrete that is post-tension cables inside of it, if you have very limited depth before crossing paths with a PTC?
So both Hilti and Simpson, we're very familiar with both those products. They have anchors that are very shallow and are designed for post-tension concrete slabs. So there is a technique, and I can't stress this enough, you absolutely must get with the engineer record for that structure and get their approval before you do anything. That is critical because they will know the details and the designs. Even when we get the construction plans for a slab like that in a parking deck, say, we always make sure that the engineer of record is part of the discussion so that they approve anything that's done. Even if you can get them involved, a lot of times you may wind up having to do a slab x-ray and determine, once you get the blessing of the EOR, you still have to do an x-ray to locate where those gaps are that you can actually install a traditional anchor.
I just want to remind everyone, if something pops in your head from one of these questions, feel free to use that chat feature so we can continue these discussions. On to the next one. How would y'all approach a ground investigation for an existing sign structure? Can you give us a little more detail on how y'all go about that?
Yeah, so there's a few ways to approach this question, but it kind of falls into our structural inspection program, which is one of the parts that I work on here. It's great to try to use existing signs. Some of the first things that we would do would be gathering all the survey information. So this information, it kind of goes more in detail than your standard sign survey. So above just getting measurements of the overall height and the stage, we would also want the thickness of the pipe, diameter of the pipe, foundation sizes. And then going even further into detail, we want to look at the weld call-outs, the existing bolts. If there's a lot of rust, we can even dig around the base of the pole, see if there's any pitting or corroding there. So that's how we would start it. And then after we gather all of that information, then we would approach it by doing an analysis of the structure, determining its frequency or, how wobbly that sign's going to be. And then we put a report back out to you and kind of give you our recommendation and repairs for that sign structure in itself.
Some of y'all are probably familiar with the International Building Code has an existing structures section, which actually in 2021 is its own book. And on its most basic level, in order to reuse an existing structure, say you want to add a new cabinet to it, an additional cabinet, or swap out cabinets, it gives guidance. One of the things is that the loading can't increase more than 10%. So all that information that Holly discussed goes into our determining what that loading is. So that's a very key part of the evaluation. But the other thing is vague. It says, as long as the structure is in good condition. And I'm oversimplifying, but this whole process, it's for say a monument sign, pretty straightforward because those traditionally aren't very tall and you may have just one stick pole or something. But when you're looking at a multi-stage structure, that can get to be a very involved inspection process. And so there's a lot that goes into determining, is the structure in good condition? And can repairs be made? What is it? So it can be a fairly complicated and in-depth and very site-specific process in order to determine that.
You're muted.
Sorry, I'm so sorry. How would y'all go about assessing the risk of failure for a sign structure?
So that question kind of rolls into question 5 as well. It's a great follow-up. So we categorize signs into 3 areas, low, medium, or high for risk failure. If you're looking at a single sign, for that report, we would get all the survey information, do the analysis, what Rob said, look at loading, if you're increasing the sign. But then we also look at, if it's for multiple signs, we can look at the age of the sign. If it's inland or coastal regions, how tall it is, how much square footage of signage you actually have with the cabinet mounted to the pole. If it's in a high wind area, a storm area. So there's differences that we can do versus a single sign, or if you're looking at a family of signs, to assess the risk failures and how to categorize those going forward.
We have a client who has a family of signs all over the country, and so we came up with a spreadsheet where we apply certain risk factors and come up with a numerical score that helps us drop it into those low, medium, or high risk. And one of the things that was interesting about it that came out as part of that process and analyzing all over the country is you know, obviously the taller the sign, the higher risk it is. You have something on the Gulf Coast that is at a higher risk because the wind speeds are higher. But one of the things that surprised me is that we found that there's a high risk for sign failure along interstates in the north. And the best we can tell, it's because they're salting the roads all the time. And as they drive over the roads, it aerosolizes the salt. And that goes up and it causes some very significant rusting on these sign structures that are located along the interstates. And so having that global perspective drew up some other factors that go into risk that were a little bit unexpected and was interesting. So taking that knowledge, we apply it to whenever someone says, hey, I've got this one sign structure and it's in, say, Connecticut. We know to be aware of that for them, and that makes it a slightly elevated risk because it's located along an interstate in Connecticut.
That was a good example. I had no idea. Has Elrod ever experienced a time when y'all's engineering knowledge was used to solve a problem that appeared to maybe not have an answer? And if so, could you provide everyone maybe a rundown on that example?
Yeah, and this is, there's always an answer. I like to jokingly say, any problem can be solved given time and money. So does there appear to be no answers? sometimes on the surface, that is exactly the case. We had a situation where we were asked to install or design the installation of an awning, a projecting awning, attach it to some window mullions. And they were projecting a little bit out from the windows. And so coming up with the attachment method, it had to be dozens and dozens of screw attachments that went in instead of a traditional method in order to support the load. But then in working with the mullion engineers, there became water flow issues related to the window mullions themselves. So we had to come up with a way to divert water. And so at times, as we were looking at it, it did seem to be an unsolvable problem, which you wouldn't really think about on its surface. I would think of an unsolvable problem as this grand and glorious problem. But sometimes it's in the real details as to how something is physically going to connect and not cause other problems that you have to get a little creative. Another time, which is, again, you don't really think about it, it's not unusual for a sign company to call us and say, we installed this sign, the inspector came out, and we didn't get it engineered, and we have to, can you make this work? And so sometimes that can actually be a real challenge because photographs weren't collected. And so we don't actually know what was done. And so trying to understand that, trying to capture that information, trying to project and interpolate so that we can show, hopefully, that what was done really works out. And while maybe it wasn't an ideal design, it still calcs out and it still meets the building code. So those are kind of general. We did a project recently that was really interesting. It was for a convenience store chain, and they do these travel centers. And they have several sites where they have bollards that are installed there's almost a 2-level, the trucks come in at a lower level than the cars do. And they wanted to have some bollards to keep either the trucks from going off the edge into the detention pond or the cars from going down into the truck area. And they had a design, and trying to determine what loads those would resist was, again, a very interesting challenge, because on the surface of it, bollards, there are design codes for these bollards, but typically the code focuses on crash resistance in the sense of you don't want somebody crashing into this building, a terrorist or an accident or something like that. So it's more defensive. But this approach was, well, they weren't really worried about somebody hitting the gas and doing a flyer off the edge into the detention pond, but it was just this semi truck is pulling through the curve. And when you have what is the design load of a semi truck? Well, it's 80,000 pounds. Okay, well, at what speed will that bollard start to bend? And will it break loose? And kind of back figuring to say, okay, client, there's no standard here, but we've determined that at 2 miles an hour, that thing's going to break past the point of no return. Is that helpful? Is it not helpful? How do you determine that? So that was really one of the more interesting challenges where we're not really sure what the answer is. We're able to come up with some results, but then there's a value judgment on the client's behalf as to, is that helpful or not? Does it need to be beefed up? Does it need to be reduced in size? Don't know. It's up to them. And it's to be determined. They haven't decided yet.
And you're leaving us on a cliffhanger. We're going to have a part 2 just to know.
Yeah.
Okay. What should PMs be looking for as to the structural design and stability of tall, high-rise, freestanding signs in the way of signage surveys, or even on lower monument signs?
So we're assuming that this question is like the PM is getting the survey back from their subcontractor. So providing that you get enough photos and information, one of the things that I would feel like a PM should be looking for is rust. Is there a lot of rust or material loss with the mounting plates, the welds, if the bolts are rusting, and then if you're getting good photos, if you can see if there are any cracks in the welds or visual defects in the welds as well, because if items like that are happening, then the stability and the structural design of that existing sign should probably be questioned. So it's just making sure that your surveys capture some of those finer details, even if you're not specifically asking for them, that you review the photos you're getting, and you can kind of point them out and then maybe have that conversation with your subcontractor that's on site and ask them to clarify a few more things.
We've been doing these inspections since, I want to say, the early 90s. And so it's evolved a lot as we've done them just based on experience. And we have developed just an exhaustive procedure for gathering the information that's helpful for one of these inspections. And partly it's just because of trial and error. We've learned you need to get this, you need to get that. And then it's also exhaustive because when you've got one of your folks up in a bucket, 150 feet up in the air, you don't want them trying to remember to take a picture of X, Y, or Z. It is laid out in excruciating detail. But all that information is gathered in, and as Holly said, the rust, the welds, how the welds are inspected visually and how they're tested. All that information is gathered and consolidated and reviewed and goes into evaluating that structure.
Why do engineers oftentimes only provide engineering for pylon foundations and poles, but not for the actual cabinet attachments to the poles?
I love this question, and I swear I did not submit it. This is a pet peeve of mine. The answer is because when you go to pull your permit, typically all the city cares about is the pole and the foundation. And they don't typically care about the attachment of the cabinet or the construction of the cabinet. And to me, that is very frustrating because you can have the pole and the foundation designed for your standard wind load of 115 miles an hour. And we have had clients with a lot of cabinets that are not designed to 115 miles an hour. That tornado comes through, the pole and the foundation are going to be great. And the cabinet's going to be who knows where, in somebody's bathroom. And to me, that is I'm getting up on my soapbox. That is a problem that the cities have. And, but, you know, the way I look at it, the city doesn't care. So why would you as a sign company pay for an engineer to engineer something that the city frankly doesn't care about? We do have some clients who say, from a liability point of view, they want to make sure it's done right, even though it's not required, which is great. When we do families of signs or prototype designs, we do, a lot of times we get into that. And so everything from the attachment points, everything is engineered, but because it's a family of signs. And, but when it's just the individual sign, yeah, it's your engineer. And I think this is consistent from, I'm pretty familiar with all of us who are doing this work. And the neat thing about our industry is we've got some really good engineers at other companies doing this work. I mean, we're all doing the same thing. It's you don't want to pay extra to have a cabinet designed if the city doesn't require it for a permit. And so we provide you what you need, even though it's a gap. Whoever asked the question, you're exactly right. It's a gap in the process. If you actually look at the building code, you can make a really strong argument that all the attachments to the cabinet to the pole, the cabinet design, everything should be engineered. But if the city doesn't require it, who does it? I'll get off my soapbox, but thank you for that question. I love that. Sorry.
Someone else submitted it, so you're good. Is there a quick calculation to roughly determine the steel size footing requirements for a monument or pylon sign?
So the short answer is yes. We're going to share our screen, and you all can take a screenshot of this. So this is a new web page that we've designed. So it's called signcalc.com. And if you go here to your estimator and just say we want to do a monument sign, so you would put in your wind speed. Most areas in the U.S., a minimum of 115 is what we design to. We'll put in the overall height of your sign, your width, and then the diameter of the foundation you want. So say you have an auger and you want to do a 3-foot diameter. And once you put in all of that information, over here is going to pop up your option for steel and then the depth of the foundation based on the diameter that you want it to be. So if you change this, so you want to do 5, it's going to change the depth again with that. And so this is for a monument single pole. We have it in a dual pole, a pylon sign. So not just a pole, but you have the enclosure for the pylon. And then our newest one here is for a post and panel sign. So short answer is this will be the quickest calculation that we could give you because it's going to do it for you. And this is just for estimating purposes. It's not going to replace the actual sealed engineered drawings.
But, Rachel, we do have people call and ask that. And you're in the middle of bidding a job and you want to know what size steel, what size foundation so that you can give an accurate bid. And we kept running into this issue of that takes time on our part to figure it. And we're engineers. All we do is sell time. That's what we do since we don't make anything. And we thought, okay, we can come up with this free tool. Mm-hmm. You don't have to register for it. There's no charge, nothing, but it's a way to estimate. And as Holly said, it's not a design. We've had to simplify some things and make some assumptions, but it's a little conservative, but it's a great tool to use to come up with that information.
Yeah, and like Rob said, it's free to use. So as long as you go to signcalc.com, it should open up on our homepage, and then this just has a drop-down box of what you want to select. And then if you need to reach out or contact us, we have a contact page here as well.
And again, we have come across some other tools that people use that I'm actually not sure where people get them. There's some old tools, so this isn't the only thing that's available. But we saw a need and we wanted to take care of our clients with it, and so yes, this is a little bit of a commercial of an answer. So, but there's some other good tools.
So we're not selling anything.
Yeah.
Well, we put it in the chat for everyone as well, a link to that.
Oh, cool.
We'll include that in when we send out the recording to the panelists. We can include that as well. That is all of the questions that were sent in by our attendees. Now is the time. If there are any last minute questions, to submit them into the chat. If not, like I said, we will be sending out a recording and the contact information for both Rob and Holly if you want to continue chatting about some of these questions in more detail. As well as Rob and Holly, we will be sending you the attendee list as well. So if there are no other questions, one final call. we appreciate, those were some great questions and some very informative answers. So we appreciate Holly and Rob. Thank y'all so much as always. And thank you to those who took the time to join us for this webinar. I just wanted to let everyone know that we do have another webinar coming up on May 1st with annual silver sponsor Impact LED. So be sure to register for that. It is open. So again, thank you, and we hope you all have a great rest of your day.
Thank you so much. This was a lot of fun.
Bye, y'all.
Bye. Thank you.